This video is going to be about how to assess normality for a variable. And so we have spent some time in the last few sections learning about normal distributions and variables that might be normally distributed. In practice, there is not going to be someone standing there telling you that a variable is normally distributed. And so we need to look at what techniques we can use to look at our sample data to try and determine if the data comes from a population that is normally distributed. And so we have some steps here for assessing normality in a variable. The first thing is to draw a histogram. And so we learned how to do histograms already. If you make a histogram for your sample data and you have a nice bell-shaped distribution, then you're likely to have a normal distribution. This is more difficult for small samples as you can't really see the smooth bell-shaped curve up here yet. So we need some other techniques as well, okay? Outliers, so looking for potential outliers. Again, we learned how to do this as well when we did box plots. We would look for any values that are above the third quartile by more than 1.5 times the interquartile range, or below the first quartile by more than 1.5 times the interquartile range. So if we have many outliers, that's usually an indicator that we might not have a normal distribution. Typically we look for 1 or 2 outliers. That might be okay, but we start getting many, and that might be an indicator that our distribution is non-normal. Again, that's just a guideline, so we're using these tools together. The third thing that we're going to look at is what's called a normal quantile plot or a normal probability plot. That is new for this section. This is a plot that we're going to do through our calculators. Usually you're going to use statistical software or your calculator to do this. And the idea here is that we are basically calculating z-scores that would be the z-scores calculated if our variable was normally distributed, and we're looking to see if those scores fall on a straight line. So if the points lie close to our line, then we would say the data comes from a distribution that is approximately normal. A lot of times I'll call this the fat pencil test, because basically if we can take our pen and we can cover all of our data points with that straight line, that's close enough to linear to indicate normality of our variable. So we're going to take a look at this in the next example. Okay, so in this example it says cholesterol data was calculated on patients 4 days after having a heart attack. The data is in the following table, and we're asked to determine if the data is from a population that is normally distributed. And so the first thing that we are going to do is we're going to do a histogram, then we are going to find potential outliers, and then we're going to look at a normal probability plot. So to do that, we're going to put our data set into the calculator. So stat, edit, and under list 1, we are going to highlight that list name and hit clear, enter to clear the list. And then we're going to enter all these values. So we have 218, 182, 240, 202, 234, 238, 294, 218, 214, 288, 220, 248, 116, 190, 200, 278, 200, 236, 220, 248, 276, 244, 186, 270, 146, 258, 352, and 242. And so once you've got all of your data values entered into your list, you're going to hit stat. We are going to need, eventually when we check for outliers, we're going to need the quartiles, and so we're going to find those right now and just jot them down. So under calculate, 1var stats, and we're going to go ahead and scroll down and and get our quartiles. So Q1 was 201. Q2, which is the same as the median, is 235. And Q3 is 253. And so we'll need those when we calculate potential outliers. So the first thing that we're going to do to check for normality is a histogram. And so as a reminder to do the histogram, we're going to hit second, stat plot. We are going to hit enter and make sure that plot is turned on. So if it was on off, scroll over and hit on and enter. And then scroll down to type, and we want to choose the third type there that looks like a histogram. You actually need to hit enter so that it goes ahead and selects that type. We're looking for list 1 to get those X values. And once you've done that, you can just go ahead and do zoom. And then we want option 9 to get the stat zoom. And there's our histogram. Okay, so what I would be looking for as far as work on a quiz or on an exam is just a rough sketch of that histogram. Doesn't have to be detailed. So ordinarily, back when we were learning histograms, I requested that you label the axes and label units along your axes. This time, I'm not as concerned with that. My main concern is that we've looked at the shape of the distribution, and remember, we're looking for a bell shape and we're looking for that symmetry. And so you'll notice that this is not perfect if we try and fit a smooth curve here, because we do have kind of a gap there, but it's pretty close. So that's nothing that's far enough from being bell-shaped that we would have too many concerns. So far this is looking fairly bell-shaped. Okay. The next thing that we want to do to try and determine normality of our data is look for outliers. Okay, and so as a reminder, we said that any value that is below the lower limit is Q1 minus 1.5 times the interquartile range, is going to be a potential outlier. And then any value above the upper limit, that's Q3 plus 1.5 times the interquartile range. So just as a reminder, the interquartile range is Q3 minus Q1. So that's going to be 253 minus 201, which gives us 52 as our interquartile range. And so our lower limit is going to be 201 minus 1.5 times 52. So we've got 201 minus 1.5 times 52 gives us 123. And then for our upper limit, we have Q3, which is 253 plus 1.5 times that interquartile range. And so 253 plus 1.5 times 52 gives us 331. And so any values that are smaller than 123 or larger than 331 would be considered potential outliers in this data set. If we look through our data set, we've got, I'm looking for small values here. We've got 116, and that looks like the only one that's below 123. And then as far as larger than 331, we have 1 as well. So we have 2 potential outliers, 116 and 352. But you'll notice there was 1 on each side, which tends to sort of indicate that you might still have this nice normal bell shape because there's 1 on each side. Another thing that we're going to look at here, as we did those outliers, it doesn't hurt to look at back to our stat plot to look at the modified box plot and just see what that looked like. So if we choose the modified box plot and do zoom 9 again, there you can see those 2 outliers, so 1 on each end. And you still have what looks to be a fairly symmetric distribution here. So you might have a little more spread on that right side, and we saw that here, but it still looks fairly symmetric. And then the last thing that we would want to do is our normal quantile plot. Again, remember we called this a normal probability plot. Okay, and that is back under our stat plot. So we went second stat plot, hit enter. And this time we're going to choose the very last one on type. Okay, so right there we're going to hit enter. You'll notice it's making sure we entered our data into list 1, and everything should be set up correctly automatically, and so we're just going to hit zoom 9. And you'll notice there our normal quantile plot. So we do have a little bit of gap here on each end, but again, we called this the fat pencil test, and you can see pretty nicely there. If I cover that graph with my pencil, every single one of those points does end up being covered. So that would be a fairly good indicator that we still had a variable that was approximately normally distributed. So for the normal quantile plot, again, I wouldn't be too picky, and I don't require that you label your axes here, but I do want you to give me a graph where I can tell that you plotted it, and so just give me a rough sketch there. And you can tell that that looks fairly linear. Okay, so putting all of those 3 pieces of information together, we would say that the cholesterol data appears to be approximately normally distributed. Okay, so that one was our first example, and then quickly I'm going to walk us through one more, just so that we can get another data set to look at here. So this one is on the size of Atlantic cod, and so we're looking at data of fish length, and we're trying to see if it's normally distributed or not. So we are going to go ahead and enter in the data, so I'll try and do that quickly. So we've got 48, 61, 42, 53, 48, 50, 48, 44, 48, 49, 50, 45, 50, 52, 52, 55, 47, 60, 56, 47, 53, 53, 54, 46, 51, 50, 46, 48, 46, 48, 49, 50, 50, 47, 45, and then finally 52, 48, 49, 48, and 47. So once you've got all those data values in there, we can look at our summary statistics. So I'm going to go to one of our stats, and I'm just going to get our Q1, our median, which is the same as Q2, and our Q3, which is 52. Okay, and we can go ahead and calculate that interquartile range now also if we want. That's 52 minus 47, which is 5. And so first thing is we would want to look at that histogram. And so if we do that, we're going to our stat plot. It's already on, so we're just changing our type back to the histogram and hitting zoom 9 again. And so you can see this one is much less bell-shaped than the one we saw last time. So this one should look to you to be right skewed. So it looks something like that. Okay, so that would kind of give us reason to be a little bit concerned that these might not be normally distributed. Next thing we're doing is looking for outliers. So our lower limit is going to be Q1 minus 1.5 times that interquartile range, which is 47 minus 1.5 times 5. So that's 39.5. And then our upper limit is Q3 plus 1.5 times that interquartile range, which is going to be 52 plus 1.5 times 5. Which is 59.5. And so because these are integer values, basically anything that's 60 or higher is going to be a potential outlier. So we're going to go through and try and find those. And so it looks like there's 2 of them, which is the same as we saw last time. The difference being that last time we had one potential outlier on the low side and one potential outlier on the higher side. This time we have 2 potential outliers as well, but they're both in the upper tail. And so we can see that tending to indicate we have more of a right skew. And so our potential outliers are 60 and 61. While we're looking at outliers, it doesn't hurt to go ahead and look at that box plot again like we did in the last example. So if we switch our type to the modified box plot and do zoom 9 and look at it, again you see both of those outliers up there in the right tail. Okay, last thing we're supposed to do is our normal probability plot. And so that's under our plot, our stat plot, and under type, we're again scrolling all the way to the last one and zoom 9. And you'll see in this one that we have that twist up there at the top, okay? And so when we're trying to draw this plot, it looks something like this. Okay. And while we're close to getting that fat pencil test work, let me kind of center it more under here under the camera. We're close, but to try and get all of those points, you'll notice we do have a little bit of trouble if we're trying to stick with a straight line. And so this is definitely not an example of a variable that is far from normally distributed, but it is an example of a variable that we would say is probably not normally distributed. It looks like it's slightly right skewed. So we would say cod length is right skewed, at least for this data set, right? Those data values that we have.